Hello friends, welcome back. Yesterday we saw how to find orthogonal surfaces, a type 1 problem to it, where we were given a function and then we will find a orthogonal surface. Today let us see an example for type 2, where we are given some function. No, let us avoid that because we know how to solve a PD, right? And if we see for type 2, the formula that we had was an easier one. Like we just had to replace small p with dx, q with dy, and r with dz and solve it. Okay, in this way. Hence, let us take a bit complicated example where you will stuck in the exam if you get an example of that kind. So let us solve that particular model. So say we are given a function phi as z of z into x plus y whole square, comma x square minus y square. Now if you observe, z is a function of z, x as well as y. How will you solve it? Because you knew how to solve f of x comma y equal to some c1. It was a function of x and y, but here you have three alag variables. What we will do is that let us say this is u and this is v this way. So this particular function we can write as phi of u comma v equal to 0. Okay. Now let us say we need to differentiate phi with respect to u. See, remember one thing. Now once we have replaced this particular thing with u and this particular thing with v, we have phi of u comma v equals to 0. Therefore, this phi doesn't know what is x and what is y and what is z. It only knows what is u and what is v. So whenever we differentiate phi, first we'll differentiate with respect to u if we are differentiating. Then we know by chain rule. See, dou phi by dou u. This dou u. Again we can write dou u by dou x. See, this dou u gets cancelled out and we are left with dou phi by dou x. Okay. Similarly, we can write dou phi by dou u into this dou u by dou z into here it will be dou z by dou x. And this I have written as p. Okay. And this type of examples we have solved earlier. So if you have any doubt, just go back and look at them. Now, this dou phi by dou v. Again, this v will get cancelled out and we will be left with dou phi by dou x. Similarly, we will be left with dou phi by dou x here because this p can be written as dou z by dou x. Correct? See, this z will get cancelled out, this v, this v. So we have differentiated with respect to x indirectly by differentiating phi with respect to u. Now, we know what is dou u by dou x from here. Put it here. Now you'll say how we know this. See, differentiate this u with respect to x. Nala. See, dou u by dou x equals to. Once we're differentiating this term with respect to x, what shall we get? 2 into z into x plus 1. Okay, that is what we have written here. Similarly, dou u by dou z, differentiate it with respect to z, it will be x plus y whole square. This is what we have written here and into p as it is. Similarly, see dou v by dou x. Here we have 2x. Dou v by dou z, no z here. So it will be 0. Hence, this entire term will be 2x into dou phi by dou v. So in the end, if I take these terms here and divide by dou phi by dou v, by just rearranging, I am getting dou phi by dou u upon dou phi by dou v equals to this particular term. Okay. Now, say, mm, mm, mm. Okay, this is one. Now, we are differentiated with respect to u, correct? Now, let us differentiate one sec. We are again making a mistake here. Though we differentiated here with respect to u, in the end we differentiated with respect to x. Similarly, now we will differentiate this 5 with respect to y. But how? Again by chain rule. See, dou phi by dou u into dou u by dou y. Okay, into dou u by dou z into q. What is q? Dou z by dou y. Okay, and similarly this one. Once we have written this, these things are easier to find because we already know u. I'll show you one. Other three things you will find on yourself. See, dou u by dou z. Sorry, dou u by dou y. We had u as this. So once we differentiate it with respect to y, it will be 2z into x plus y. Okay, that is what I have written here. 2z into x plus y. Similarly, dou u by dou z, it will be x plus y whole square. And here dou v by dou y equal to minus 2y. And this term we already knew. It is 0 as what we had v. V was our x square minus y square. No z term in it. Okay. Now again we will rearrange it into dou phi by dou u upon dou phi by dou v. And this is what we are getting by rearranging. Now if we see equation 1 and equation 2, LHS is same in both of them. So RHS has to be same. So we'll equate both of them. Once we equate, this is what we will get. Then cross multiplying and simplifying. Here we have tried to simplify and just simplifying, we reach here. Okay. This is simple simplification. Just go through it. We'll understand. Now, once we get this, what is it? 2z plus py plus qx equals to 0. This can be written as py plus qx equal to minus 2z. Again, same thing can be written as qx plus py equals to minus 2z. Now, this is the surface that we are given. And we have to find orthogonal surface to this particular surface. Which? This surface. And what was the formula that we saw earlier? It was pdx plus qdy plus rdz equals to 0. Okay. So, this is p and this is y. See, let us compare this. pp plus some qq equals to r. Okay. So, if we see this y is p, this q, let's write it again, pp plus qq equals to r. See, this q, this q is same. So this x should be q, r should be minus 2z. So just writing here, this is in the form of pdx plus qdy plus rdz equals to 0. Okay. Now this particular term we can write as d of xy minus 2dz equals to 0. Just integrate it. We will get xy minus z square equals to c. And this is the required orthogonal surface. Okay. So while solving a difficult question, we reached into a differential equation which was type 2 to solve to get an orthogonal surface, and we solved it to get its orthogonal surface. So we are done with type 1 and type 2. Okay. See you in the next video. Thank you.